In a previous section, we'd walk through the first two beats for writing a literal, and so we had these definitions that involved binary and decimal and hex, and then we displayed those in beat number 2. So now we're moving to beat number 3, which is signed literals. All right, so the code for this is here. All right, so we start with some definitions in Verilog. So we have a reg, and we don't say that it's signed. So the default is if it's not designated as signed, it would be unsigned. So U is an unsigned value that's represented in Verilog of a hex A5. So that's a bit pattern, all right? And so we know how that bit pattern works. There's the A and there's the 5. All right, so when I look at this, all right, and I want to take a look at some display commands. All right, so the first one, we're going to take the unsigned value, okay, and we're going to show the bit pattern. So %B would give that in binary. So I run this and I get the bit pattern 1010, that's A, 0101, that's 5. All right, that's what we expected. And then the decimal value of that, because it's unsigned, you just convert that and you get 165. All right, so that works as you would expect. All right, so for the next one, this next command, we have S, and S has been designated as signed. Okay, so Verilog knows we're wanting to represent this as a signed number, but the bit pattern is the same, right? So when I show this, when I run it, you get 1010, 0101. That's a bit pattern for a signed number, okay? But how would you interpret that if you showed this in decimal? So because this is showing in decimal and because Verilog knows it's supposed to be signed, it looks at the signed bit. The signed bit is a 1, so we know that's a negative number, okay? And so as we've done this before, we would do this interpretation. This would be minus 91 instead of the unsigned version, which would be plus 165. Okay, so the next part of this display thing is just showing once you know something is signed, you can do some arithmetic. You can add another signed number. So if I started with minus 91, and I added a signed decimal representation of 1, so minus 91 plus 1, when I run that, I would get what I expect. S plus 1, minus 91 plus 1, you get minus 90. Okay, so the next example is a place where you could run into some confusion. I doubt if you're going to encounter this very much, but I wanted to point out this subtlety. Okay, in this particular case, what we're going to do is we're going to put a negative sign in front of a literal. Okay, and it turns out that when you do that, you get something that's a little bit odd, okay? Even though that's a minus sign, if you don't say, you have no way of telling Verilog, you're not putting it as a signed register. So it's just going to take this, and it's going to take this minus 5, and it's going to negate that, which would be the 2's complement representation, okay? And so that would show up there because of the minus sign, okay? So you can check that for yourself. If you take 5 in 8 bits and then flip all the bits and add 1, this is what you get, all right, because of that minus sign here. All right, and if you then showed that value in decimal, it's just going to take that as unsigned because there was no way of telling Verilog, hey, I wanted you to do this as a signed interpretation. So that's kind of subtle. If that's escaping you, don't worry about that now. But if it happens, if you ever have a negative literal and it's printing as an unsigned when you're expecting signed, that's probably what's going on. Okay, so that's the thing I wanted to talk about with representing signed numbers with Verilog.